Hello, statistics students. Here is another video on the binomial model. In particular, we're going to be looking at how to find binomial probabilities by hand. And in the end, we will see a formula arise from our work. When the number of trials is small, we can find probabilities by relying on the probability rules in Chapter 5 and listing all possible outcomes because the number of trials is small. In fact, there's a general pattern we can exploit to find a formula that will give us the probabilities for any value of the number of trials n and the probability of success p. Listing all of the outcomes will help us see why this formula works. So we're going to be looking at the Zener cards. Suppose we're testing someone using the Zener cards that have 5 different shapes. So you've got these set of Zener cards, and there's 5 different shapes that could appear. So after each card is guessed, it's then returned to the deck, and the deck is shuffled before the next card is drawn. We want to count how many correct guesses a potential psychic makes in 4 trials. So the psychic is going to guess at what shape is shown on the card. And there's 5 different outcomes, and we're going to record whether or not they guess it correctly. So for the outcomes of this experiment, the psychic could guess 0 correct answers, 1 correct answer, 2 correct answers, 3 correct, or maybe they got all 4 of them correct. So the first step is to list all possible outcomes after 4 attempts. At each trial, the guesser is either right or wrong. Using R for right and W for wrong, we'll list all possible sequences of right or wrong results in 4 trials. So here we've listed all possibilities. So for right, there's only one way to get this. You would have to guess all 4 of them correctly. But to get 3 right, we have 4 different ways that we could get 3 right. And getting 2 right, there are 6 different ways that can occur. And 1 right, there are 4 ways. And 0 right, there's only 1 way that can occur. So in total, there's 16 possible outcomes. Remember, the number of trials being 4, there aren't a lot of outcomes, so we can list them all. Now, keep in mind, though, all of these are not equally likely. So now we're going to find the probabilities of getting 4 right. Then we'll look at the probability of getting 3 right, and then 2 right, and then 1 right, and then 0 right. And we'll be able to create the distribution of these probabilities. Because there are 5 shapes, and all 5 are equally likely to be chosen, if the receiver is simply guessing and has no psychic ability, then the probability of a right answer of a single trial is going to be 1 out of 5. You have a 1 out of 5 chances of guessing it correctly, which is 0.2. And then the probability of guessing wrong is much higher because there's going to be 4 out of 5 ways that can occur, which is 0.8. Okay, so what are the ways that we can get 4 right? We saw there was 1 way this could happen, R, 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 R. 4 right means that we would have a right and right and right and right. Successive trials are independent, meaning if we guess right on the first one, and guessing right on the second one will be independent of what we guessed on the first one. It's because we replace the card and we reshuffle every time. So by the multiplication rule of independent events, the outcome of one event does not affect the outcome of the other. If A and B are independent events, then the probability of both occurring is just the product of their probabilities. The probability of A and B is the probability of A times the probability of B. So for this one, to get 4 right, the probability that we get them right is 0.2 on each one, and we want all 4 of them. So we multiply 0.2 by itself 4 times, 0.2 to the fourth power is 0.0016. This probability is just that binomial probability of 4 trials with a success rate of 0.2 and getting 4 right. The 1 is in there because the 1 times the 0.0016, because there's only one way that we can get all 4 right to happen, which is also why there's only one outcome in the 4 right column to the right. Now, how do we get 3 right? So we saw there's 4 different ways that can occur. So the probability of getting 3 right and 1 wrong includes all 4 options in the second group. The probability for each of these options is obtained by calculating the probability of 3 right and 1 wrong. And all of these probabilities will be the same. So in the first position right, second position right, third position right, and the fourth position wrong, we multiply those probabilities 0.2 times 0.2 times 0.2, and then one of the 0.8s is 0.0064. To get the total probability, then we would multiply by the 4 in that column. So the probability of getting 3 right and 1 wrong in any order is going to be 0.0256. Now, this is the binomial probability of 4 trials, success rate of 0.2, and getting 3 right. And notice that that's 4 times 0.2 cubed times 0.8 to the first. Remember, we're trying to generate a pattern here so we could see the formula. Now 2 right. Remember, there were 6 ways that could occur in that column under 2 right. The probability of getting 2 right and 2 wrong includes all 6 of those options. And the probability for each of these options is obtained by calculating the probability of 2 right and 2 wrong. To get 2 right, we would have to do 0.2 times 0.2, and 2 wrong, 0.8 times 0.8. That's 0.0256. Now, because there were 6 of them in that column, 6 different ways, and each of them have a probability of 0.0256, the probability of getting 2 right and 2 wrong in any order is 0.1536. Now, this is just the binomial probability of 4 trials, success rate of 0.2, and getting 2 correct. And look at the formula. 6 times 0.2 to the second, 0.8 to the second, 0.1536. So we're starting to see this formula that we can use to calculate binomial probabilities. Now, 1 right. We saw 4 different ways that can occur. So that includes all options in the 4th group. So we're going to obtain the probability for each of these options by calculating the probability of 1 right and 3 wrong. So now we only have 1 right. So we're only going to have 1.2 in there. And then 3 wrong, we have to multiply by 0.8 3 times, which gives us 0.1024. And because there were 4 of them in that column, we multiply that by 4 to get that probability of 0.4096. So the probability to get 1 right and 3 wrong in any order is 0.4096. Now, this is just the binomial probability of 4 trials, success rate of 0.2, and getting 1 correct. And again, we start to see this formula, 0.2 to the first times 0.8 to the third times the 6 for the number of ways that that can occur. So that's a rather high probability there, 0.4096. The last one, to get 0 right, we'd have to get wrong, 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 wrong. The probability of getting all 4 wrong then is going to be 0.8 times 0.8 times 0.8 times 0.8, which is 0.4096. And there's only one way for this to happen, so we just multiply that by 1. So the probability that we would get 0 right and 4 wrong is 0.4096. And this is just the probability, binomial probability of 4 trials, success rate of 0.2, and getting none of them correct. And as we did before, we see the formula is 1 times 0.8 to the 4th power, which is 0.4096. Okay, so what do we do with all this? We're going to summarize this in this table. So we calculated these probabilities to get 4 right at 0.0016, 3 right at 0.0256, 2 right at 0.1536, and to get 1 right was 0.4096, and 0 right is 0.4096 again. Now, because this contains all of the cases, when we add all of those numbers up, it should be 1 because it consists of all of those probabilities. And so when we add all those up, we should get 1. And so we should always check that. And so putting these into the calculator, 0.0016 plus 0.0256 plus 0.1536 plus 0.4096 plus 0.4096. And that gives us 1. So that's just to double check that we've done everything correctly. Okay, so we see that we get 1 on that. So let's look at the distribution. This figure shows a graph of the probability distribution. Notice how this graph is right skewed. And that's because the probability of success is less than 0.5. We have a higher probability of guessing none of them correctly than 4 of them. A much higher probability of guessing none of them correctly. We have a pretty high probability of guessing 1 correctly, but to get all 4 correct, really small number. So this approach of listing all possible outcomes is tedious when n equals 4. And once you start getting larger values of n, it becomes much more tedious. For n equals 5, we'd have to list 32 possibilities, and for 6, 64. So it's not really realistic to do this by hand. So from the patterns, we can see how a formula can be derived. And the results that we get, we see by using StatCrunch, are based on this formula. So StatCrunch has a program inside, and we don't see all that stuff when we go into StatCrunch. But it's nice to know how the computer does it. And so we saw that the probability of X successes in n trials of a binomial experiment from the pattern above. First, you have to figure out the different ways of getting X successes in n trials, and then multiply by the probability of success P raised to the X power, and then multiplied by 1 minus that probability P raised to the n minus X power. Now, I know that formula looks a little bit tough, but when you see it in action, pretty straightforward. And so remember, though, that this formula is the same as the binomial probability that's done in StatCrunch. So, for example, for our alleged psychic who gets 4 guesses with the Zener cards, the probability of 3 successes, X equals 3, in 4 trials, n equals 4 with P equals 2, is, putting everything into that formula, we saw there were 4 ways to get 3 successes in 4 trials. The P is 0.2, so we raised that to the 3rd power. And 1 minus P is the probability of failure. So that's the 0.8 raised to the n minus X. So n being 4, X being 3, there's 1 left over. So those exponents on there are always going to add up to the number of trials. 3 plus 1 is 4. So then you multiply 0.2 out 3 times 0.8, and we get 0.0256. And you could check this by going to StatCrunch and checking that this is the same thing as the binomial probability of 4 trials with a success rate of 0.2 and number of successes 3. And you will see that this is 0.0256. So in summary, This video allowed us to generate this formula to calculate binomial probabilities by hand. In practice, we do this using technology, but knowing how the formula works and where it comes from helps us understand binomial probabilities much better. And this concludes this video on the binomial model and finding probabilities by hand.